I think we've got too many people. Here, I'll send you my link. See if it works. I'm gonna send you a link. You got it? You got it?
Is it on? All right. Start out. All right. Okay, so. All right, so I'm going to take this from something my kid does in class. All right, clap once if you're with me. Clap twice if we are with me. Clap 3 times if you're with me. All right, so good night and welcome to the September meeting for the Google Developer Group here in the Twin Cities. I'm Jeff Williams. I've got the first presentation that's followed by Stefan Lewis, and after him we've got another talk by Dan Liu. It's going to be a great night tonight. First, I'm going to talk briefly about Google Classroom. Anybody tried Google Classroom yet? Nobody. Did you feel like you were in a classroom when I made you clap like that? Yeah. All right. So we're getting there. We're getting ready to think about what it would be like to be in Google Classroom. And there's not yet an API, but there are some ways you can kind of interact with it because it integrates with Google Drive, and Google Drive has an API. So first I'll introduce it. So back in my Google introduced Google Classroom, a tool to help teachers communicate with their students, manage and organize work that they are handing out to students, and especially work that's being handled in Google Drive. So when you've got one file that's one assignment and you want to have every student have a copy of that, this provides a way to do it where it'll make a copy of that assignment and put an individualized copy in each student's Google Classroom folder with a subfolder for your class. And it keeps pestering them about the due, etc. So it helps a lot with organization. It doesn't contain ads. Right before they introduced it, there was that big thing about they're no longer going to be scanning student email and recording or whatever, advertising based on email contents and stuff like that. And it was really funny, like a couple days after they say they're going to stop being evil about those kind of things, then they introduced this. So I think that might have been related in them wanting to make everybody believe that everything is great and good with with what they're doing with the content that you put into Google Drive if you're an educator or a student. So the classes show up like this. This is kind of the home screen that you'll see on Google Classroom. And after I'll show you my home screen. So over at the University of Minnesota, we're just testing it. We're trying it out. It's not turned on for the masses yet. So one of the other people, Peg, she has created a painting class. And the home screen for me shows her class and my class. I like having a class and assigning homework to people. I've already done it a couple times. And let's take a look at what a class looks like. It looks kind of like a blog type format, right? Or any other sort of a scrolling sort of a thing where the old information is at the bottom and eventually pages off to additional pages, and the new information is at the top. So you can always post the newest information up at the top as a teacher, announcements, assignments, and students can go back and they can comment on those in real time, and you'll get an email notifying you that someone has commented on the thing that you put out there, so you know you're prompted to come back into this interface. If you assign something, you have time to turn it in. They asked, what's your favorite hobby? So I turned in a picture of a rock climbing wall. And then I said what it was, and I found out that somebody else that I work with also rock climbs, so now I'm going to have another climbing buddy. And even where it was. So you turn in your homework, well, it's submitted. The teacher is the only one who can edit it after you've submitted the homework. Just like in real life, you take the physical piece of paper homework, you give it to the teacher, it's in their control, you can't do anything with it, but they can return it to you, and when they do, then you have edit access over it again. On a picture, it doesn't make so much difference, but when it's a Google spreadsheet, or a picture, or a Google Doc document, that makes a big difference, because you wonder, why can't I edit this anymore? Oh, it's because I turned this homework assignment in, so now I can only view the work that I've already turned in, I cannot edit it. And then it'll come back to editing mode once it's been returned to you, graded or not. If it's ungraded, probably they're sending it back and saying, this is unacceptable, redo it, turn it back in, and then I'll give you a grade for it, right? And so far I've been a really lenient grader on the classes I've got. Let's go back over here. So my class is called Learn Google Classroom. And I had a couple assignments already. I asked a couple people if it's good or bad, and 2 people turned in their work. So I graded them each 100 of 100. I was really happy that they actually got their stuff together and got it turned in. And I returned the homework to them. Okay, and if you click on them, you can see the chat that you had back and forth with them. It's all really slick and that really nice interface, but there's not a lot of features yet. That's going to change in time. You can see when they submitted it, and that one was easy. Submitted it, and I returned it when it was graded. You can click to see the work. It takes you over to Google Drive, and this was a Google Docs document, so it takes me to Docs. And now that it's back in his control, I would be making suggestions of suggested edits. I would no longer be, I don't have any edit rights over it, okay? So it says you are suggesting. So if I made some change, it says it's not clear, I can delete not, and then it's marked out and it indicates that there's a change that I'm suggesting. So close that out. But that assignment, it had a name automatically, the name of the assignment plus his name following. So this is the format they do to make it easy for the teachers to know whose homework it is when you look in your own Google Drive. And here I'll take a look at Google Drive and I'll see. In Drive, you get a folder called Classroom. Oops, I'll go up to Classroom. Get a folder called Classroom. In Classroom, let's see if I can shrink this over. Oh, well, that's fine. Over in Classroom, you get a folder for each class that you've got. And when you create a new class, you get another folder. So this is where you could do some API integration. You could use the Google Drive API either just to poll and find out if there are any classes that this person is teaching or a student in. And teaching, you can find out because there are templates that are created for the teacher. The teacher will make a document and try to share it with a class, and that creates a template. So you'll notice that there's a template inside. So I'll go to my Learn Google Classroom OIT class, and you'll see this templates do not edit folder. That was automatically created by Google, and that indicates that I'm a teacher, but also, and the check folder as well. And I have not edited yet to see what would happen, but I suppose I could do that too. And then on a class that you're a student in, all you see is the work that you've submitted for that class. In this case, it was a picture of a climbing wall, right? So you could find out that someone's in a class or teaching a class. You could then find out, you know, look and see in your course management system at your university or school, is this a valid course name? Is this a course name that we actually have here? And if it was a valid course name, you could maybe email that teacher the list of all the students that they should paste in as students to join that class. It does not have right now, like I mentioned, an API for you to be able to automatically populate students into the different courses. So when you go and you create a class, you're adding the students by hand, or you're inviting them. When you invite them, there's an invite code. An invite code is this same address that's up in the bar up here, the same code up there. You could send that to someone. They could go into Google Classroom and they could add that exact same class if they're in your same domain. This is something that people are really frustrated about right now. And in the message boards, there's a couple things people are most concerned about with Google Classroom. One, can I be a teacher and have another person also be a teacher with me on one course? We're co-teaching a course. Right now, no. Isn't a feature they have yet, but they're absolutely committed to adding that. Because in this post right here, they keep getting the smackdown, and other posts like it, and then they just gave up and pinned it to the top so that people will see. Stop asking about that. We know, we're going to do it. The other one is that you can't have teachers and students in different Google Apps domains. They have to be in the same exact domain. A lot of universities and especially K through 12 have put their students and staff and faculty in separate domains for management reasons, because it's easier to manage the settings and controls for students versus teachers by having them in completely separate Google Apps accounts. So umn.edu would be University of Minnesota. If we had that sort of arrangement, maybe it would be students.ufm.edu where the students would be. And then you would have two different zones that are completely separate Google Apps accounts, and then you could have one be limited to, say, no email, for example, if it was students. Not so much for us, but for K-12, maybe the little kids don't get email, but they get to have Google Drive. And maybe they don't get Google Calendar, or they don't get Hangouts, something it would be deemed that they're not appropriate to have yet. So you can't be in a different class, so that's one concern. Those are the two big ones. Was well, they would build, yeah, they do want to build more things that are safe for kids, so that kids won't be, yeah. And that's one thing, people are complaining already about this. So let's say I'd invite a bunch of people, I really mean to share their email addresses, but okay. Invite a bunch of people to the class, and then they would come and they would join the class. And, you know, when their assignments due, they'll hear about the assignments, etc. At the end, I'm done. I'm going to give them a grade. I'll go to each of my assignments, and I'll go and I'll download. If I download, it'll give me the grade for that one assignment. There's no overall grade book yet that goes across all of the assignments. So there's some things that they're still working on. Now, like there were these 3 people that didn't finish their assignment. If I click on that, it's really easy for me to just go and email them and say, hey, what's up? You know, get with the program. Your homework was due yesterday, or whatever you want to say, right? So Google Classroom, I think I'm past 5 minutes, but let's see. So you can assign stuff. You can use push notifications to have Google let you know when something changed. So if you're a developer, you could put a push note, a request for a watch on the Google Classroom folder that each of the students or faculty have. And then when that changes and somebody adds something to that folder, you can get a callback, a webhook callback from Google. They'll then let your app do something, be able to do something by seeing that, you know, hey, right now there is a new folder in here, so somebody just added a new class. This teacher added a new class. So that's the one way you can right now interact with this in a quick way and not be resource intensive. If you don't mind pestering them every minute, every day, you could just do polling and keep checking to see if anybody has added any classes. And they're likely to have an API. It's the early days. It's a really slick tool, and I wouldn't recommend it though for a real big use as a course management system yet. But if you're going to do something small, like if I was going to train half the people in this room, great, no problem. It would work slick, and but by the time you get to be a pretty big number of them, though, it's a little bit less convenient. The neatest thing, though, is that ability to have it automatically take a document that you choose to make an assignment and have it share that out to people. I'm just going to show you. I've got a picture. It's one of these. I'll just open them up. Of that. So I took some screenshots when I was first playing around with it. And it comes up as a Google app. It was off. I turned it on. Oh, here it is. So make a copy for each student. So that's the neatest thing. So you just choose that you wanted to attach a Google Drive document, and students can view it, students can edit it, or make a copy for each one. And that was the best and most helpful thing. And that replaces some of the functionality of third-party tools that people have been using, like Doctopus, for assigning out homework and pulling it back in to grade it. They would each get their own copy that they can edit. Now, if they have edit rights and then they add somebody else to it, then that might be cheating. It depends on what the rules are. So you got to set the rules of the game with them so that they know whether or not to use this really, really collaborative Google Drive in a collaborative way, or if they're not supposed to use it in a collaborative way. And that'll be for any of the teachers to decide. So it's the early days. It's pretty cool. It's free, and try it out. And if you can. If you can't, it's free for education, and that's the main market of it, though. Business it'll probably end up one of the apps that's allowed for business to turn on, but you know, they kind of phased out all those free accounts, so I don't think there are any more free accounts coming in for Google apps. So it's all, you know, the $50 per user per month kind of, or per year rather, kind of a thing. Unless you go to Google Apps Unlimited, which has no limits on drive space and adds an extra $10 per month. So good times. Any questions?
Probably free because they're trying to sell more Android tablets market.
They're trying to do more tablets, not just Android tablets, also Chromebooks. Chromebooks are a big business now. Isn't that right? Our Chromebook resellers who are letting us use their wonderful space. Not our like university, this are like our like us as a community. Yeah. Okay. Anyway, any other questions? No? Good times. All right, so now you can say that you've seen Google Classroom. Yay. Oh, and it sends really nice email notifications of things. So,
So you plug it in and you hope it works.
That's the technology.
And then if it doesn't work, you turn it off and turn it on again. And let's see how advanced we're gonna get here. Maybe. Oh, just really slow. I think that's because we're hanging out. So if you guys don't know, we're actually recording these and broadcasting them both live by Hangouts Live, as well as it's going to be available after on the GDG channel, I hope.
Yeah, the page. Google Plus page.
The GDG Twin Cities Google Plus page. If you can't find it, ask one of us. I was here to talk primarily about building Chrome apps. So I'll be kind of diving into a little bit about those, but I want to just start off with a couple questions. So most people here are developers. I think I've seen almost all of you before. How many people have developed mobile apps or native apps of any kind? Okay, about 3/4. Okay. How many are just purely web? Okay, about another half. So I'm here to talk about Chrome apps. Just a little bit of background on me first. So I work for a company called MentorMate. We're located uptown We imagine, design, and deliver mobile and web applications. Today is actually my 13th anniversary of the company, so been there a long, long, long time. What about myself? So I've worked on over 700 plus projects, everything from startups to Fortune 500s. So my role at the company is really trying to help evaluate, okay, what is the best way to solve the problem? And with this kind of exponential explosion that we're seeing in all sorts of technology, the answer changes kind of week to week, day to day, as well as based on the problem that you're trying to solve. Some of my credentials, I'm also a Google developer expert in Chrome. So I'm going to start with the idea of Chrome apps. So how many people here know what Chrome apps are? And maybe I can make it as, okay, how many people of those who know what they are have built one? 2. Okay, 3. So I'll go into some of the background. Chrome apps are really trying to solve a couple problems. Web applications, they don't work offline. And I'm making these kind of categorical statements with a few caveats, right? So you can make a web application work offline with cache manifests and all sorts of kind of wizardry that actually Google hates. But it doesn't work well offline. And then the second piece is harder to charge and monetize those pieces. Absolutely, you can go integrate with an authorized .NET or a PayPal or a Google Wallet, but out of the box, it doesn't do that. And so the idea is, by a Chrome app, this is a platform that I'll keep describing here, you're going to try and solve both of those problems. So I want to talk a little bit about Chrome, because there's this really maybe half evil, half pure good strategy that Google has been following that no one's really talking about, which is the idea that you've got Windows as a development deployment platform, you've got Mac as a deployment platform, you've got iOS, you've got Android, and for the most part, these are kind of silos, right? You've got PhoneGap and Cordova and Xamarin and all these cross-platform frameworks. But none of them have a single binary that you can run across the board. But if you look at Chrome, this idea of Chrome as a platform, you actually have Chrome on every single one of those devices I've talked about. Everything from Chromebooks, Linux, Windows, Mac, FreeBSD, all the way down to tablets, phones. It's kind of amazing. I think the only platform that does not have some version of Chrome is like Windows Phone. And we'll see if that ever picks up enough market share to warrant it. But by doing this, what they've done is they've made kind of this combination of Blink, so the Chrome rendering engine, as well as kind of Safari WebKit, become the de facto standard for if you want to write an application and make sure it's going to run everywhere, you can write it targeting Chrome as a platform. The idea of building a Chrome app or a Chrome packaged app, it's also known as, is you're going to be building an application that you can actually distribute via the Chrome Web Store. So today, Google has not opened this up for mobile deployment, but I'll talk about a few ways that you can actually use a Chrome app and actually target mobile applications as well later. But so primarily this is right now desktop and Chrome OS devices, where you can actually just go in the Chrome Web Store, pay $4.99, get a copy of Lucidchart or get a copy of Diagrammer or whatever sort of application you want, and it's going to work across all those platforms and using kind of targeting a single rendering engine. Looking at a little bit about the history of the Chrome App Store. So when it came out, it was back in December of 2010. It was announced back in Google I/O of 2010. It really had nothing of value at all. So just really these terrible wrappers, I call them. So you had diary.com with no functionality. It was just an app that was a link to the web page. But what that started was it started a foundation upon which kind of they developed more and more API calls. They developed more and more native functionality as they extended this idea from an extension to an app. And I'll talk about that in a second. But if you look at it kind of as of September 2014, it really is a modern app development and distribution platform. So you can build an application, you can sell it, you can charge for it, you can monetize it, you can distribute it, you can maintain it, and people rely on these things more and more, especially with the Google Apps integration and add-ons and those things. Looking at some of the heritage, so we all remember kind of these Firefox add-ons, so there will only be Zool or whatever the phrase is. Then we had Chrome extensions, so when Chrome first came out, it didn't actually have those capabilities, so then they added those back in, and then that's actually when the Chrome Web Store came out. And then they created this third generation, which is called Chrome Apps, which really takes the idea of a Chrome extension and extends it a huge degree. So Chrome extension is designed to interact with existing applications and websites. A Chrome app, however, is really not designed to interact in those same ways. A Chrome app is a pure, true application that is running on the machine using Chromium and the rendering engine as a way of delivering that application and running the code that you're writing. So Chrome apps, to talk kind of about the construction of them, they really have 4 parts. So the first part is a manifest, which I'll talk through, that really tells the Chrome Web Store as well as any device they're going to deploy it on, what is this thing? Then you've got a piece of JavaScript that actually starts it all, which is called your background file. Then you've got a set of foreground windows, which I'll talk about what that looks like. And then you've got a set of APIs that make the whole thing kind of flow and connect and actually meaningful. So starting with the manifest, so I understand this is too small. I have a link at the end to the presentation if you guys want to download it and see it. There's several important parts. So you've got a manifest version. So they originally had, when it was just Chrome extensions, they had manifest version 1, and then they updated it and saying, hey, we want to offer all these new sorts of capabilities. Then you define all the metadata about your app, who you are, what version it is, what version of Chrome it requires. Then you have a set of assets that you can target a number of kind of densities. And then you've got this idea of your app. And so in your app, you can actually be running different types of scripts. And the core one is called a background script, or background.js. It's most often named. And then the last piece is that very much like iOS and Android, there's a permissions model. So when I go to the Chrome Web Store and say, hey, I'd like to download and install this application, it's going to say, hey, this person wants to look at your location. They want to know who you are in terms of identity, and they want to be able to send notifications to your screen. And so you agree to all of those things, and the developer can ask for all those things, which basically turns on and off the security model for a set of different APIs. The second part of a Chrome app is this background.js app. This is the standard one. If you build any sort of application, you're going to get something like that. What it does is it listens for an on-launched event that comes from Chrome. It will only work in a Chrome app situation. And what that does is that creates a window on screen using that same rendering engine. You can just size it, and it can be resized later. And then you give it an HTML file. So when I give it that HTML file, what I'm actually going to end up getting is something like this. So you'll notice there's no tabs here. There's no URL bar. There's no omnibox. So it's taken away almost all of the functionality except for the system close, maximize, things like that, as well as resize. And then whatever you put in that index.html file, just like you would a standard web page, it's going to end up looking like an application. And that's powerful in a variety of different ways. Because it's just standard HTML, CSS, and JavaScript. So if you've built any sort of application, you can actually go and take it here. One of the caveats to that, and really the only caveat, is the content security policy. So this is a policy that really serves 2 purposes. The first is from a security standpoint. It's really easy to write web applications that randomly, arbitrarily execute code, really coming from anywhere. A lot of people are doing script injection, right, where you're downloading a script, and then that script injects another script tag, and that's pulling off of who knows whose web server. So that's something that can happen very easily, and they said, hey, because these are kind of pure applications, we don't want that to happen. And so the content security policy is a set of restrictions on that that control how you interact with the internet. And the second purpose of that is it's not a web page anymore. They really want this to be an application that runs completely offline and then accesses the internet for resources via basically AJAX calls. So if we look deeper into the content security policy, there's really 3 restrictions that it institutes. 1, you can't load remote resources from HTML. So that means I'm not supposed to just input a script tag that pulls jQuery off the internet. I actually have to embed that with my application. You can't inject images. So after my DOM is loaded, I can't just go and get additional arbitrary code, even for my own application. And then the last piece is it actually forcibly separates your HTML and your JavaScript. So a lot of people, I mean, whenever the first version of every application you've ever written with JavaScript, you put it right in the page, typically, which I always have. Not allowed to do that. Everything has to be loaded via JavaScript and then modified via DOM manipulation. So get document or get element by ID, things like that. This kind of forces you in several single page applications. So you absolutely can launch as many windows as you want, just like Microsoft Word would launch many windows. But in general, when you're just modifying state within a single run of your application, you're actually going to be doing that all within a single HTML page. There's kind of 6 pieces to a standard single page application. So this is the idea of chunking. So instead of going out to the internet to get a full page, I'm just going out to the internet to get a JSON object. And then I'm going to load that JSON object, parse it, and then load the appropriate view within my own application. Controllers, so the idea that just like in Angular or a lot of these MVC frameworks, I want to separate the logic, so I'm going to have something that controls that view. Templating, so I mean, none of these are required necessarily for a single page application, but they end up just being kind of standard good ideas for building an application of this type. Routing, so let's say you were trying to build a text editor in as a Chrome application. So you're going to have several states of the application, right? So you're going to have a state where you haven't loaded a file, you're going to have a state maybe for browsing your files or browsing your project, and then you'll have a state for viewing a file. You don't want separate windows for those, so you're actually going to be staying within the same kind of index.html file and then doing routing via JavaScript for where the user should be and what should be displayed on the screen. Wikipedia lists real-time communication as a requirement for a single-page application. I think that's dumb. I don't think you actually need that. I think kind of user-based polling or kind of timer-based polling is just fine. But then the last piece is local storage. So if I had to go out to the internet for any application every time I wanted to modify data, it would take much too long, and it really wouldn't be a great user experience. If you think about this shift a little bit, so normally you have a client, a very thin client, typically the browser that's calling the server, then you make a click, and then you call the server again. It's much more like this, where you've got a thick client, so you've got all your JavaScript, HTML running locally. A user clicks, you handle that click. A user clicks, you handle the click. And then you make a separate asynchronous call out to the internet to actually go and fetch data, load state, and things like that. There's a lot of APIs that come as part of Chrome apps. And this is actually one of the things that, from my perspective, makes it much better than building a web page. So these are some of my favorites. So runtime, you can actually access the state of the runtime. You can control it. Window, so you can actually control windowing. So let's say I did want to build a text editor. I want to be able to have multiple windows that actually interact autonomously with the operating system, which is very nice. File system access, so you can go out and get files just like a normal application. You can't do that via HTML, kind of pure HTML today. Google Cloud messaging, so if you want the application to wake up in response to a server event, instead of doing the polling, you want to do push notifications, you can do that. Internationalization. Number 6 here, identity, is actually one of my favorites. So because every user has downloaded the application from the Chrome Web Store, you don't need to worry about asking them for a username and password. If you ask for the identity permission, all you do is you say, who is this user? And Google will tell you, which is kind of very powerful as a developer of an application, the idea that once they've paid, once they've installed this application, I already know who they are, and I don't need to create extra registration steps and things like that unless I want to. Notifications, so you actually interact with either the Mac, the Windows, or the Linux notification toolbars. And then the last one is storage and sync file system. So if you don't want to go out and do actual file system manipulations, but you want to store some local data, they will actually give you a storage file system or a sync file system. And what that will do is if you have an application, I mean, most of us who have used an application have used it on multiple devices. Using this, as long as you've done the sort of identity authentication, they will actually synchronize the state of your application automatically across all of the devices. So whether that's they use Windows and Linux, or whether they have a work PC and a home PC, or even now, if they have a mobile device using a Chrome app and a desktop PC, their data, their preferences, you don't need to store those things. You can just throw it into a sync file system via JSON, and it will automatically sync those things. These are cool APIs that I think are very exciting, but I've not used any of these, so beware. They actually have USB device controls now. So if you want to go build a piece of hardware that interacts with a scanner or a printer or something like that, you could theoretically go and write those drivers for yourself. They have an audio API. So let's imagine a desktop application sometimes needs to be able to interact with kind of different audio setups, right? Maybe you have one stream of audio going to your television, one going to your speakers. Or maybe you have an 8-channel system. You can do those sorts of fine-grained controls here where you can't do that via the web. Human interface device. Location, I think I actually have used that one. Sockets and TCP. Not only can you consume by TCP and not just HTTP, you can actually create a TCP server. So you could build Node.js as a Chrome app and actually launch that. And you see some cool things being built today that we're going to kind of see extending. So how many people here know who Kush is, or Kush? Okay, a few people. So he's a very prominent developer in the Android and CyanogenMod communities. he actually built his latest version of Allcast Receiver, which is a mirroring app. So you download the Allcast Receiver for Android, and then he built a TCP server that actually listens and receives those connections as a Chrome app. Serial port, so just like USB, Bluetooth, just like serial. And then there's also kind of a set of system commands that you can run. There's some other cool things that you can do when it comes to building Chrome apps rather than a web page or other ways of deploying applications. Native client. How many people here know what native client is? So native client is a way of building applications that include C and C++ in a Chrome app, basically. So you can write code in C and C++, a game engine, whatever you've got, and that will actually work directly in your application. And then there's also some kind of cool things you can do in terms of compiling JavaScript down to C++, but that's dark wizardry from my perspective. But there are some benefits to being able to do this that you can't do today. So there's security of code. So if you've ever built a web application, everyone has your code. I see this every day where clients, customers, fantastic web developers will build an application that you can then go in and tweak the variable directly in your dev inspector, and then it just updates and flows through. So having a compiled piece of your application does increase the security of code. There's also C and C++ code portability. So if you already have something built for maybe iOS, Android, you can actually use it here. There's a huge performance boost to using C++ or C, even in the web. So it's about 15% slower than just running C directly on bare metal. And I put "you hate freedom" because I kind of love the idea that I can go in and modify anyone's code and see what they're doing. So it's a bit of a mixed bag, but it's an exciting thing for developers. I mean, if you're building the next Unreal Engine, you don't want people to go and see all your code and be able to kind of decompile that and run it themselves. The next cool thing that I've talked to a lot of kind of other conferences about is mobile Chrome app. So there is now a project called Cordova Chrome Apps or Chrome Cordova app, where you can actually now take your whole www folder, which has your manifest, it's got all your files, your index.html, your background.js, and it will run it as a mobile application. And so they've implemented something like 8 out of the 24 APIs already. So that identity, it works on iOS and Android, Google Cloud Messaging. So all these things will work automatically. So all you do is you take your Chrome app and you run it through, it's actually a wrapper around Cordova, and it will convert it into an application that will run on iOS or Android. So one of the examples everyone does is this idea of a to-do, right? So here you've got that custom dedicated window that's running directly on the platform as an application, and then you get that exact same thing on a mobile, which is very exciting. Dart, so I don't know if there's a lot of Dart fans here. You can build Chrome applications in Dart. Right now it's still through the compatibility layer, I think, but in future versions, they're absolutely going to have native support for Dart. So if you're a big fan of Dart, you can actually build full applications using the same APIs that way. And one of the things that I actually discovered from Lloyd is the Chrome Dev Editor at the last GDG meetup. I keep getting sucked more and more into this tool. It is a fantastic tool. And if you actually look at it, it is a Chrome app itself. So they built this in Dart, compiled Dart to JavaScript, and then deployed it to the Chrome Web Store. So this uses the file system API, this uses a single page application layout, and then it actually is a development editor that allows you to build Chrome applications. Not only is it a Chrome app, but you can actually select in the template dropdown, Chrome app. It will give you your kind of standard window or index.html, your background page, your manifest, and then if you hit the little run button in the corner, it will run it in the browser. So if you guys haven't tried that out, definitely check that out. Yeah?
Is that only for Chrome apps or for any web app?
So the Chrome Dev Editor is for any app that is JavaScript based or HTML based, because it starts just basically a little HTTP server, but it also integrates with Chrome, so you get access to all those APIs.
I can use that to build any web page.
Correct. Well, so not like server interpreted languages or compiled languages like PHP and Python, but you could absolutely build a whole web page using Angular, and that's a lot of their templates are based on Angular, just purely in this tool. And it keeps getting better. I mean, when Lloyd showed us about a month ago, it would take like 20 minutes to download packages, and we had no idea what it was downloading, but now I think that's gone, and it kind of just works out of the box. Then anyone else use that? Do you like it? Mm-hmm. Yeah. So and yeah. Yeah. So often I will work on Chrome apps in the Chrome Dev Editor, which is kind of a weird dog food type of idea. The only challenge is I haven't been able to commit any source code. So it's got a Git client. It does not have a Git client with push or commit capability, which is probably the most frustrating thing in the universe. Yeah.
I had to use it like all the time.
Sure.
It's nice that it's quickly updated. So I changed code using like a IntelliJ client like that. I changed something like quickly. They just totally instantly changed that. Same file. Yeah.
Yeah, it's pretty cool. And I mean, if you're on the same file system as something else, then you can have a dedicated Git client. It's funny, there are HTTP-based Git clients today, but they haven't re-implemented it using the socket library, so they don't work with non-conformant Git servers. So like Bitbucket is a very popular Git server. They don't support the proper Git standards. So whenever you try accessing it via HTTP, it actually returns the web page instead of the Git server. So then you can't commit to Bitbucket by any sort of Chrome app yet, until someone rebuilds that Chrome library using that new API, the more powerful API. Some other considerations. So unless you're using native client or NACL, don't trust the client. You're still building an application that can be debugged, inspected. Someone can find what memory you've got, you can find what they've got in the sync. So be careful in terms of what private keys, et cetera, you store in your application. OAuth is amazing. If you're not using it for everything, you probably should be. It's a very powerful way of ensuring those security credentials and being resolved in the right way. So it was something like a week ago, I built an application in about an hour that had a custom form that collected data and then submitted that out to Trello. And I really didn't have to write much code at all. It was something like 40 lines of code. Thanks, Daniel. So now you've built the coolest, best application ever as a Chrome app. What do you do with it? So the first thing you do is you test it. So if you ever go into the menu, little hamburger menu, and go into extensions or more tools, I think, in Chrome 29 or 39, you're going to get this little extension window that shows you all of your extensions. And then you're going to load unpacked extensions. And then you just point it at the folder where your whole structure is. What that will do is that will load it, and then you can launch it directly from here, or it'll show up in your standard kind of Chrome app menu. And then also from here, you can inspect any of the views. So let's say you've got both a background page and then 3 windows. You can go and inspect them individually. Then, let's say now you've built and tested the perfect application. You just take your folder, you add it to a zip, you go on the Chrome Web Store, and you go to the developer dashboard in the upper right-hand corner under the settings. It costs a lot of money. It costs $5 to sign up as a developer. So I know that cuts out a lot of people, but what's that? Yeah, no, this is not monthly. It's forever. No, it's not an annual $99. But it's required. You have to verify your account. And then, actually one of the cool things is if you're on a Google Apps domain, you can actually publish applications only within that organization. So you can build a private tool for your company, deploy it so that it runs on everyone's Chrome computer, because everyone at some point is going to run Chrome. And then you don't actually have to pay that fee. So big savings for the company. Question? Yeah. Yeah.
What do you, if anything, what do you use for your like
So I'm not a unit testing expert, but it's any JavaScript framework. So if you use Grunt or if you use any of the JavaScript test frameworks or test harnesses, those will all work perfectly with this application. So just like you test a web application, or a single page application or Angular, you do the same thing here. No, you absolutely could. Yeah, I mean, you could have the test harness instead of loading that main window. I won't go there. Load the test harness. So then you could have two builds of your application. One that's the test, and you just hit refresh, and then it will run your tests, and then you run the real thing, and you see the real thing. I've not talked to people about test framework. More about kind of what cool things are they building and what frustrations are they running into with the new APIs. So like, I mean, the APIs, they're exciting, they're new, but Bluetooth, for example, is hopefully out of date. I mean, it's very kind of raw at this point. Not a huge number of people are writing Chrome apps. It keeps increasing. I mean, if you just look at the quality of the App Store, I mean, there's a number of Chrome apps I use now personally, which wouldn't have happened 4 years ago. So I think as more people use it, they're going to figure out, okay, these are the APIs that people actually care about, and refine those. Because I mean, we're going to get to a point here within the next 2 years where you've got, I mean, Jeff's got a mood sensing EEG headband. Wouldn't that be great to interact with just a Chrome app that works on Linux, Mac, Windows, and mobile out of the box? I mean, that would be a dream. And then you could charge for it because you're not just building a web page. Are you going to wear that the rest of the night? Yeah, I should have made you wear that so I knew if you were paying attention. Any other questions? Yeah.
When you use view someone else's code by putting in random variables, what exactly do you mean by that?
So I mean, any non-obfuscated set of JavaScript, and even some obfuscated JavaScript, I can go run the Chrome Development Tools debugger and inject state, break things. I mean, it's far easier than, for example, debugging C.
So not like you just can't figure that out.
No, I can't use, but that's exactly the difference, right? PHP, everything's being run and controlled by the server in a way, in a black box that I can't access or I can't see. When you switch that to a Chrome app architecture, all of your code inherently is running locally. I mean, if you get a project of sufficient size, it doesn't actually matter. I mean, for example, you could go and modify or inspect the Gmail interface, right? That's a single page application for the most part, but it's not going to be meaningful to you. But if you build a little 5-minute script to submit things to Trello for you, they could go in and look at your private key and things like that and figure out, okay, what are the IDs you're submitting to, which it is a security concern at some point. Yep. Have you had experience with TinyMC debugging? Okay. Yeah. Can you obfuscate things with Shadow DOM? No, because you can breach the Shadow DOM veil. You can obfuscate. I mean, there's a million ways to obfuscate code. Yeah. Sure. I would say, I mean, a lot of them are from Google. Just speaking frankly, I mean, the Hangouts is a Chrome app. I personally really like Lucidchart. The Chrome Dev Editor is fantastic. What else do I use? I use an SSH client. I use a VNC client on the Chrome App Store because I've run hundreds of SSH and VNC clients over the years. I mean, Putty being almost #1 always. But every time I go to a new computer, I'm setting up Putty again. And if I can just store that in Chrome and then instantly have access to all my servers, all my credentials, things like that, that's easier for me. I can check. See how dangerous I'm willing to go here. No. So here's some of the Chrome apps. So as I said, VNC, slides. I mean, so a lot of offline apps are more powerful when they have Chrome apps behind them. So Gmail offline, Calendar offline, Drive offline, those sorts of things, hugely leverage offline apps. Remote desktop, I'm a big fan of. secure shell VNC. There's some games. Yeah, that's primarily what I use. Yeah.
The security policy, is it domain specific, or does it go down the path?
No, it's because there's no domain. It's all your application, right? Yeah. So you can go get anything you want from a server, but because there's no eval and there's no script injection, you can't get code and run it. I can go get any JSON object or HTML snippet I want, but I can't do anything in code.
Right, but you can go to different servers.
Yeah, but you have to request those permissions. So as part of, I mean, one of the most common permissions requested is access all URLs, which kind of defeats the purpose of the permission system from that perspective, from an AJAX perspective. But I mean, when I install a Windows application or a Mac application, I expect that it might be going out to different URLs on the internet. And the same expectation is true here. I mean, you're opening up your computer to some degree to that application to run in the background, to respond to push notifications in a way that a web page never will. Yeah.
I don't understand the C++ interface.
Sure.
Trying to run this on a small Linux system where you wanted to get a very quick user interface.
Sure.
Not have to go through all the rigmarole. So exactly how did you get access to your C and C++ libraries inside the app?
Sure. I'll go back to just at least the architectural diagram. So basically what happens is there's a little wrapper around, okay. So normally you're building just kind of HTML, CSS, JavaScript, but then you can actually include a native client module that exposes all of those kind of APIs, the header file, via JavaScript. So there's a translation layer there that allows you to interact between the two. And then, I mean, you can use any of the standard HTML features like web workers. So for example, let's say you wanted to have a little C++ daemon running in the background, which you probably shouldn't do, it sounds dirty, but you could. You could load that via a web worker and then run that.
I was thinking more along the lines of they wanted to ship device IO.
Sure. So the native client is subject to the same restrictions though as the HTML, CSS, JavaScript. So unless there's an API exposing that, you don't just have you can't just arbitrarily call kernel or make kernel commands, things like that. So you're sandboxed within Chrome still.
So your C source has to be recompiled by some kind of format.
Correct. Yep. It is. I don't think it's compiled. I think it's translated, but.
Essentially.
Yeah. Yeah.
How does one get hooked with Chrome developer expert? What does that do?
It's the same for all the Google developer experts. You have to get nominated by a regional lead, I think, and then there's a submission process, and then a review, a set of interviews. Yep. So then they judge you on community contributions in terms of documentation. No, 2 interviews. There are exactly 2 interviews. Yeah. No, it's mainly human. But then, I mean, they judge you based on what source code you published, what talks you've given, things like that. Yes, so the first interview is with a Google developer expert. So I'm sure Daniel's given an interview or 2.
Give an interview or vote for SJDs?
Yeah.
I sure have. Yeah.
All right. Any other questions? All right. Thanks, guys.
Sorry, how does this work?
And then what's the hookup for? I don't know.
Flip it over. Yeah, that's better.
All right. And how do I hook into this?
Do you have an adapter?
I do have an adapter for VGA. I'll have to go grab it. Yeah, I've got one too. If you, that looks a lot like mine. All right. All right. Cool. We can wait a minute while people grab new beers or dessert. I'm just glad this all works. That is kind of like the motto for technology. Glad it all worked. I had a certain level of amazement. So one of the first mobile apps I wrote was Hotel Pal, which was like booking hotels on Android. And this was like 5 years ago. And we hooked up with Travelocity's backend, and you could book a hotel. And I actually booked a hotel down in Iowa and showed up and had a room, and that was the most amazing thing to me, despite the fact that the app had been out for a few months and people had theoretically already been doing that. But it was just, I couldn't believe it worked because I'd written it. All right, welcome everyone to my talk about Android interpretive dance. No, this is about custom views on Android, which is something I've been getting super duper into in the last year. I know that GDG isn't all Android people, so for the non-Android people, this talk may be a little boring, so you can check Twitter all you want, I won't care. The first half should be a little more generic, the second half will be a lot of technical stuff, so it'll be pretty boring for you at that point. So custom views on Android, a view on Android is basically the basic building block of your visual part of your application. So everything you see on Android is built out of views. And the basic framework comes with a lot of views that are very handy, like text view when you want to show text, and image view when you want to show an image, progress bar when you want to show progress. But there's this other side to it, which is that you can actually write most of the things that Google have written themselves by just extending view and writing your own code. But for a few years, this was my view on custom views, which is this complicated mess. You can kind of look in, you can see it, it's open source, but I didn't ever want to touch it because it just seems really complicated to me. And why did it seem really complicated is because I would look at the framework library classes. And these are the lines of code as of the API 19. I checked them a few days ago. The base view class is almost 20,000 lines of code. Text view is almost 9,000 lines on top of that. The list view class, it looks like it's only 3,800 lines of code, but that builds off of abs list view, which builds off of adapter view, which builds off of view group, which builds off of view, which is a total of 38,000 lines of code about. And I'm not going to do a custom view. That seems insane. You go to the documentation, and you see that these are the methods that you can override in order to make a custom view do whatever you want. And this actual graph, this actual table is in the documentation. And I think it does nothing but scare people away, because this is freaky. Seeing all of these methods that some of them you've never even heard of, like on trackball events. Like, when was the last time an Android device came out with a trackball on it? So the key takeaway, if you take away nothing else from this talk, is that the library views, the framework views, are not the custom views that I'm trying to promote here today. If you are writing a view that has to be used by every single Android developer in existence, then yes, it'll be complicated and it'll be hard to write and get it just right for every single circumstance. But if you're writing custom views for yourself, you don't have to worry about all the other, like, hundreds of thousands of Android developers out there in the world. All you have to worry about is your application. And you can write such simpler code because you're just targeting your app. This talk focuses mostly on just simple custom views that make your life so much easier in development. So why might you want to use simple custom views? The main reason is two reasons. You have a view that you want to customize, You can use it in any part of your application at this point. It might be a little hard to see on the screen, but these are three different views from Trello. It's like the main board view, archived items, and the cards that are assigned to me. And each one of them, they have like a card view, which is like this little card view thing here. And that is actually the exact same class in all three circumstances. They're all in different adapters, they're all in different fragments, and then sometimes they're doing different activities. But it doesn't matter, it's one single line of code to bind all of my data in all three of these spots. So the reuse value is huge, especially if you have a large enough application where you're going to reuse some parts of your UI. A second big thing is encapsulation. When I write a custom view, I can pass off all the logic to that custom view. I don't have to worry about what's going on in there anymore. So in this case, here's the members view on Trello. I've got two views up here. One is, they're both me. The top one is my tester account, which doesn't have an avatar, and the bottom one is my actual account, which does have an avatar. And what I wanted to do is, in the case of not having an avatar, show the acronym for the user's name. But when I do have an avatar, I actually want to load it with Picasso and like show it in that nice little view. And so if I wasn't writing with this with custom views, I'd have to write some utility class. I'd have to remember to call that every time so that the utility class would examine the member and make sure that if the member didn't have an avatar, it loads this, loads that, whatever. It's a lot of work every time I want to add this user view. If I have this all as a custom view, I can just say bind this member to this view. And that view remembers all the logic it needs to do. If I ever change the logic, like I don't want to show the acronym anymore, or I want to show a color, because that's become pretty common in Google Apps these days to show just a random color to associate with different users, I can easily change that and it changes throughout my entire application. I don't have to worry about duplicating that logic anywhere. A third huge advantage is compound views. And so, a custom view doesn't have to be something extending text view or image view and it's just this lone thing on itself. It can be a combination of multiple views. So in this, the Movies app, each one of those grid squares is actually just a single custom view. So I can just access the higher level view and not worry about the contents inside, and then encapsulated within it is all the logic to display the different aspects of the little movie icon. A fourth thing you can get is XML styling. So a lot of the times, if you extend a custom view, you don't want to have to define everything at runtime. You might want to just define things in XML because it gives you the power that the whole resource qualifier system in Android gets you. You can write your own attributes. In this case, I'm doing just the classic problem is that you can't actually set fonts of text views, or at least not until very recently, in the XML itself. So I wrote my own little font text view that can allow me to apply Comic Sans and Papyrus whenever I need it for the best looking app. One other big part of custom views is you can do custom drawing routines. You can set up whatever you want. You don't have to be limited to just a single drawable. In some cases, a drawable still makes more sense, but sometimes it's really complicated. In this case, there's actually two custom views on this screen, and the one I want to draw focus to is this kind of flight trip view, which is these little blue lines which show the different airports that you would be having a layover at and how long the layover would take. And you could do this with a bunch of views, but it'd be a lot of work. It's a lot easier just to have one draw routine with a canvas and a bunch of measuring code. Another big thing is you can really help performance. Like sometimes doing something on Android would take a lot of work, or you can write a single custom view and skip all of that work. So in this case, we have these label views. When I first started working at Trello, we can have up to 6 labels on a card. So it's those little orange, red, yellow, purple, blue, green labels at the top of each card. And when I got there, it was actually implemented as a series of views in a linear layout, which makes sense. The linear layout you can use to distribute the weight equally, so they'd all be about the same size. But the problem is, you're getting this each card has 7 views associated with it for these labels. So that's 7 views of having to inflate every single time I have a card. And this is just the phone UI. On the tablet UI, there can be like 25, 30, 40 cards visible at a time. So that's a lot of views to be working on without much benefit. I just replaced it with a single view. And all I need to do is tell it which colors to display, and it just says, okay, I got this amount of space, I can just divide the space evenly and draw it. So it's kind of custom drawing in this case, but it's custom drawing specifically just to get performance. Because I could do this with normal views, but it's a lot faster this way. And then the last thing that I love doing with simple custom views is just awesome stuff. This is something, I don't even think this is out in the app yet. I don't think we've released this yet. I just came up with this idea while I was writing this talk. But we have this view where it tells you all of the actions that have happened to a card. And it has kind of a relative time. It's a little hard to see on the screen, but it says, you know, for each of these actions, this happened just now. This happened 3 minutes ago. This other action happened 4 minutes ago. If you were to be staring at your phone with the screen on, it wouldn't update. You know, I could look at it an hour later and it would still say that this happened 3 minutes ago, even though it happened an hour ago. I set up a relative time text view, which hooks into the time tick broadcast receiver on Android. And so every time a minute increments on the system, it says, oh, the minute incremented, I need to update what I'm showing in this text. And it's just this, and so I've now pushed out having to ever think about that problem to the view. And that's just super awesome. So there's one, I don't want to say it's all roses. There is one big downside to custom views, especially the small, simple ones that I'm trying to promote here, which is that you really lose view composition. And that's just because it uses inheritance for all of these views. You can't extend one view and extend another and then combine the two extra functionalities you added. So for example, my text view I was talking about earlier, where I can show Comic Sans and Papyrus, those, you know, edit text also extends from text view. So suppose I want to use Papyrus everywhere. I also have an edit text, let's say, where whenever the user's focused on it, I give them a little X mark in the corner that allows them to clear whatever they've been typing in. Now I want to combine these two, but I can't, because one extends from text view and one extends from edit text. So there are certain cases where you don't want to extend views. You want to, in particular, you should kind of avoid them when the functionality already exists in the view, and that seems pretty obvious, but like I would say there's a lot of times that people don't look enough to see what's happened. Like I've seen people rewrite text view in order to show a hint, or edit text in order to show a hint, not realize there's like a hint attribute there. Like you could subclass view every time you wanted to get a view click listener, but that would make no sense. It'd make a lot more sense just to attach a view click listener and be able to jump on board with that. And the other thing is, especially relating to custom drawing, if you can just make a custom drawable, that's a lot more powerful. Because with custom drawables, you can apply it to any view. You know, I can make a custom drawing image view, but then I can't make it as a background of a frame layout somewhere else. But if I have a custom drawable, then I can apply it wherever I want. So if you're thinking about custom drawing, I would promote going to a custom drawable first, unless it seems like it's too much hassle. And if you want to get into custom drawables, I highly recommend watching Cyril Maudier's talk that he gave drawables, because it's awesome, and custom drawables are way out of the scope of this talk, but you should definitely watch that if you want to learn about custom drawables. So let me just run through how to create a custom view. What are the basic steps you need if you've never ever done this before? All right, so step one, we're going to extend a view. In this case, you can extend any view that you want. In this case, I'm just going to extend view because I'm trying to go for as simple as possible. But if you want to extend text view to like do the font thing, it would make more sense to extend that and then to extend view and then have to re-implement those 9,000 lines of code involved with text view. The second step is that you need a constructor. It won't compile without one because of the way Java works. Every view has a lot of things that it needs to do in order to spin up and get running. So I've defined my constructor. And then in step 3, I need to add it somewhere. So I create a new custom view with my constructor, and then I add it to a view group. And that's it. So thanks, everyone. I will hope you all enjoyed the talk. That's all you need to know about custom views. OK, so that's a very simple custom view. It does nothing. It's not even identical to view. It's actually less powerful than view for a very technical reason I want to go over. So I wanted to take one simple example and give you a few illustrative reasons why I might use a custom view here. So we're gonna take the idea of a user view, and my user view is gonna have a face on top of it and then the name below it, and that's pretty much all there's gonna be to it. That's what I want the final product to look like. So how would I do this without custom views? Whoa, for one thing, I got rid of the circle. No, it might be hard to do without custom views. So this would be the layout that I'm using. It's a linear layout with an image view and a text view. It's pretty simple. It's not too complicated. I wouldn't worry about writing down all the details of this. And then when I actually want to use it in code, it's kind of a lot of code. Like I need to get a layout inflator. I need to actually inflate that view. I need to find the text view and the image view and then bind the data myself. And in this case, there's a little like user view here, and that the user view just has a name and an icon in it. Or not a user, the user data class has a name and icon in it. So this is without the custom view. It's a lot of code whenever I want to use it, and it's a lot of code in the XML as well. So how would we do this without with an actual custom view? So in this case, I'm going to make a class I call user view. And it's going to extend from linear layout, which is the base layout of my original non-custom view version. So there's a few interesting things here. First, I have to set the orientation and gravity, which is two attributes that I wanted, manually in code. Because for reasons that I'll see in a second, I'm not going to get access to, I'm not going to be able to do any XML inflation for the actual root view itself. And then below, I have a set icon and set name, which means that I kind of encapsulate the different views inside of my view. So no one outside of this needs to know what's going on the inside. They can just call these views from the outside. The most interesting part about this is this line of code here, where I'm doing a layout inflator, and I'm inflating a user view inside of my custom view. And so what this does is the constructor creates the root view, and then the layout inflator adds all the rest of the views that I need for this custom view. And if you've used layout inflator before, you might be like, hey, this looks like the way that everybody said you don't use layout inflator. You're supposed to have a third parameter, it's supposed to say false. And there's most of the time that's true, but not this one time. This is the one time it will not be true, because what we want to do is merge that layout with this root view. And the way you do that is by having your layout have a merge as the root view there. So what happens is when I inflate it, the image view and text view become children of my user view. And I don't end up with any extra views out of this. So that's all pretty cool. The inside is still exactly the same as before. And here's the view now when I actually want to add it to the layout. I create a new user view, and then I bind some data to it. It's 3 lines of code, and it's already a lot better because I don't need to worry about any of the internals here. I don't have to know what views I'm interacting with directly. I don't have to understand what the layout is. If I need to change something about the user view, I can do it anytime I want. But can we do even better? Can we encapsulate it? Yes, we can. I love making a bind method that basically says, take all of the data and apply it to this view. All the data that I want at once and apply it. So instead of having those two methods, the set icon and set name, I'm just going to have a bind method that takes the user. And in that, I know what to do with it. I know to take the image and show it there in text. But like the member avatar view I said before, now I have the luxury with bind to say, well, if there is no icon, then I could show a name or something like that. And now, when I actually add it in code, it's 2 simple lines of code. And this is awesome. It's easy to reuse, and it's easy to modify. So this is like the main reason I love custom views, is just because it helps encapsulate all of these different problems. And so you can, like a lot of programming, I feel like is just splitting up a much bigger, harder problem into smaller, easier to solve problems. And with just the compound views, custom views, you can split up your view problem. What else can we do? For the things I listed earlier, we can do XML styling. So suppose I want to do this really ugly thing where I tip the avatar. It turns out this is really easy to show off. That's why I'm doing this, even though it looks really bad. I'm not a designer. So the first thing you need to do is declare what attribute you actually want to style. So in any given resources file, you can use declare stylable and set a name for the kind of class of different attributes you're creating. In this case, it's useful just to call it the same name as the custom view that you're using. You don't have to. There's no magical binding that happens at runtime. That's just convenient. And then you give, inside of it, you list any number of attributes that you're willing to apply. And in this case, I want to tint it, and the format's going to be a color. That format field could be whatever you want. It could be a reference to a drawable. It could be an integer. It could be a Boolean, whatever. So once I've created that, what I can do is I can go in code and use a special namespace to access all of the stylables that I created on my own. So there's the normal like XML namespace Android here, which shows you like all of the normal Android layouts, different attributes they create. And then I have this other one below it called XML namespace app. And that one has this magical incantation, res auto, which basically imports all of my stylables that I just declared in the last step. And so then I can use the namespace app :tint to define a tint color for my image, or for my user view. Now when I actually get into the user view, what I can do is I can call this thing called context.obtain styled attributes. And this is something that I find not to be rememberable. So I like to have a custom view or something, or maybe you can use this slide later, just because this code, like the typed attribute code is not like something that ever sticks in my head for whatever reason. But once you have the styled attributes, you have this typed array, which you can use to grab those values you just set in XML out of. So in this case, I'm calling typed array.getColor with the stylable user view _tint. So that's basically saying I want the tint color out of this. And then the second parameter is transparent. That's if someone didn't provide a tint, that's what the default is going to be. And then after that, you recycle it because they use some special stuff to make it very efficient. And then I set the tint, and that's pretty much all there is to it for the XML styling. Now, there's one thing that if you were really eagle-eyed and paying attention, which you may not be, happened is that the constructor changed in a very subtle way. Before, all the constructors I showed you had a single context as its parameter. And in this one, and there's all this thing called attribute set in it. And actually, if you create a custom view, if you extend view, your IDE is going to yell at you saying it needs a constructor. And then you're like, okay, sure, I'll hit the shortcut to create a constructor, and you'll see these three options. And if you're anything like me, you'll be like, what is the actual difference between the three? And I'm here to actually tell you what the difference between the three are, because the documentation is really bad about this. The basic one, the one with just the context, that's when you inflate the view in code. You give it a context, but it has no attributes that are going to be set for it automatically. The second one with an attribute set, that attribute set represents everything that's been passed in from XML. So when you have a view being inflated from XML, it actually looks for that constructor by default. And if you're going to have the view inflated in XML, you need that second constructor. So actually, a lot of the times, what I do is I only define the second constructor, and then if I happen to need to inflate it in code, I'll just call it with a null attribute set. Alternatively, you can have the first constructor that just calls this on the second one. And there's this third one, which has a third attribute, the default style attribute, which is kind of not really necessary most of the time. So what this one does is something really, it's a little clever, it's a little complicated. Where basically, suppose that I want all of my user views in the app to be default tint blue to start with. But I want the user to be able to also define a default tint of all of their user views. In that case, what I can do is I can apply a theme which defines the default for the typed array, which is, if that seems like a lot of steps, you're right. You don't really need to do that for simple custom views. But I thought I'd just mention it here, just so you don't really have to worry about that third one most of the time, unless you're actually going to write a library view that other people are going to consume. So let's get to custom drawing. Let's get to the actual circular user view that I was looking at earlier. Now take in mind, this is a prime example of where it'd be better to use a custom drawable versus using a custom view. But for the purposes of this, it's hard because if I were to show you the source code of the flight strip view I showed you earlier, I can't, one, because I don't work there anymore. It's not open source. And for a third reason, it's also like 200 lines of code of special canvas drawing stuff. So actually, I don't even remember if it's 200. It might be more. This is the only one I can simplify, and I'm going to simplify it with a yada, yada, yada. But basically, all you do whenever you want a custom drawing is override the onDraw view, and then set up whatever you want, and then you can just start applying things to the canvas as you feel fit. In this case, I'm going to use a trick that's outlined, like there's a link at the bottom right for what the yada 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 is. So this post from Roman Guy about how to you create this single bitmap shader, and then you can draw a bitmap in a circular or rounded corner fashion, which is really cool, but kind of out of the scope of this talk. But let's just yada yada yada. I configured the paint to do some really cool stuff, and then all I have to do is call canvas.draw circle. So that's kind of custom views in a nutshell. All you have to do is override on draw. And if you're doing something really simple, like you just want to change the tint color of something that's not an image view, you could just override on draw really quickly. So performance. I wanted to talk just a brief second about how you could actually improve the performance of this user view. User view is really simple, and so I would probably say don't do anything to it. Prematurely optimizing will just typically lead to sadness. I thought of one or two things that I could show off for how to actually make it go faster, but it all seems like I'm worried that I would lead people down the path of micro-optimization. I will say that one thing that you could do is the one idea that could have taken place, you could customize the on layout of the user view itself. Because right now it extends from linear layout, so it has to run through all of this code that linear layout normally does of apportioning space for every single view. Because I control all the views inside of my user view, I know where everything's going to go. I'm not worried about handling any other situation. So I could write a custom on layout that just says, yeah, I got a user view and a text below it, and that's it. And it runs super fast, which might be nice if you had like 100 user views on the screen at a time. But typically, I wouldn't go to that level. I do know that I went to a talk on the Google Play Store, and they said they were doing this extensively for a lot of their layouts. That a lot of their layouts were having slowness issues because they were using relative layouts everywhere. And so they knew ahead of time, we're going to have a view that has a single icon in it. We're going to have a different grid, a few different grid configurations that we know about. We can just write a view group that automatically apportions everything correctly. So that's pretty much what I had to talk about views. I just wanted to kind of give people an idea of what the things are you can do with simple custom views, how they can really speed up development and make your life easier. So is there any questions?
On measure, and like use that.
No. So this is like I said, I was kind of cognizant of the fact that not everyone here is going to know Android. I didn't want to go into the really like nitty-gritty parts of it. I'm going to probably give a longer version of this talk later that will go into the nitty-gritty, and I'll talk about things like on measure and on layout. But for the really simple views, no, most of the time I'm not changing on measure or on layout at all, because the default measurement's fine. And you can, that's actually one of the really nice things about custom views is I don't have to worry about all the situations it's going to be in. So in particular, the flight trip views where I had that revelation, because I was like, well, all right, what's the measurement going to be? How am I going to figure out what the minimum size is if someone passes me wrap content for this weird, complex drawing view? And then I have this breakthrough, which is, I'm the one who's creating this view. I'm just going to say you can't pass it wrap content. I'm just going to say it has to be, it's going to be 64 density independent pixels tall, or it's going to have a set height, it's going to have a set width. Because when I know that's true, my life gets so much easier. And so I just said, yeah, fine. And then I don't have to implement on measure, I don't have to implement on layout, because I know that I'm just setting up a particular size.
Not really a question, but when you're dealing with the console, for example, like if the custom drawable, correct, you put a line on the space, it becomes much easier to accommodate.
Yeah, custom drawables are super awesome. And everybody should check out Theorem Audio's talk about them, because it's really good. And it covers some issues that I've run into in the past and torn my hair out over. And then he's like, you might have smashed your keyboard before about this. Let me tell you how to fix it. I'm like, if only I'd watched that. If only I had seen this talk years ago. Anything else? Oh yeah, I forgot to mention one thing. That samples link at the top. So I always make sure that when I'm giving a talk, I'm not just spouting off a bunch of BS. So all of the user view stuff you saw, I actually did go and implement. And I implemented it better than the versions I showed here are shorter so that the font can be big enough that maybe people in the first row can read it. if you actually go to the GitHub account, it'll have like what I consider the full versions of the user view that has all the details that I would probably include. So if you want to check that out, it has information about how to make the views that I showed. No yada yada yada. It'll have everything in there.
I have a quick question. I saw that merge. But see, that's an actual keyword.
Yep. Yep. Yeah. I mean, let me jump back to that. It's an actual keyword, and it's not very often used because it's not. It doesn't make sense most places. It makes sense here because I want to define most of my view in XML, but I don't want to find the root view. And it's also used, have you heard of the include tag? You can use, just like merge is used there, you can use an include tag, and that will point you to another layout, which it'll basically just whole hog take the other layout and put it in. And if you use a normal view, then literally the whole thing moves in. If you use merge, it does the same thing. The layout, the include tag disappears and it replaces it with these views. So merge is not used very often, basically is the thing. All right. Cool. Thank you.
Well, thanks everybody for coming. As Jeff said at the beginning, we meet monthly. Next month, I think we're back to code 42, which is for our workshop tonight. We're starting early stage planning for the DevFest season. We had that last year in February. It was great. If anybody's really excited to help run a big event, to Stephen Jeffrey. Huge thanks to Agosto. Everybody from Agosto representing has stepped out, but thanks to Agosto. Be sure to thank them, Carolyn or Paul, or someone who worked here. To get a chance. They organized and sponsored the food. They also stepped up for to be Chrome Cloud, something, the top level sponsor for our group. So we'll be partnering more with Agosto throughout the year. So look forward to more events here and more. Kevin, do you want to say anything to the group? So next month is code 42 for workshop night, and we're always looking for people to talk about projects you're working on. There's a form to submit on the UC page, or talk to Jeff, Steve, or I, and let us know.
That group is an interesting talk.
Yeah, so later on this Thursday in the evening, I think, the .NET group is talking about some page applications. Like people are talking about using Angular, the JavaScript engine for that. Tomorrow night is Angular meetup. Are there other meetups where we talk about different ones as well? Anyway, lots of stuff. Sure, do you want to say anything about that? Yeah, the next week there'll be another weekend in November. We'll likely do a boot camp tonight again as we've done in the past. I'd love to have somebody volunteer for Android. We'll run an Android session and be about it. That would be great. Thanks everybody.